Slides. The next presentation is Ignas Bagdonas, who's going to be talking about something along lines similar, and I can't remember the exact title. There it is, the programmatic interface to routing. Make sure you stand relatively close to the mic.
Good day, and thanks for that. So continuing on a rather similar topic, just in a completely different direction. This is how to get application out of the router and not running certain applications in it. If you look from the end-to-end perspective of what is the routing system as such, there are two components. There's a network, which from application perspective can be seen as a dumb pipe, and then there is an application, which from a network perspective is seen as a payload. There's a lot of engineering effort put into both of these components, and they both result in certain good outcome, but not necessarily both of them coordinate. And without such coordination between those two layers, it's not always possible to achieve the, say, at least imaginary optimal result. How much the network as a transport entity is aware of application requirements. How flexibly application can utilize what the network potentially can provide to that. So yes, indeed, this is in the context of the fashionable SDN topic these days. Just slightly from a different and I would tend to say more from a practical perspective, in the sense that what can we reuse of what has been engineered for the several decades, and what potentially can be extended and not redone from the beginning in the area of interworking the application and the network. And this is based on the work which is mostly actively happening in I2RS, Interface to the Routing System Working Group in IETF. So just to present what is happening there, discuss some use cases, and the biggest interest from my side would be to gather the feedback from your community, whether this seems to be at least an acceptable approach, whether this solves any of the pain points which you might have, and what can be fed back to the IETF on how this idea can be evolved further. So, first thing, decouple two planes which we have, the control plane, and this is the topic of this. Leave the data plane aspects aside. That's a platform, the platform implements that, and let the platform control that, and of course it knows it the best. If we use, or if we define some interface into the control plane in order to augment or change or modify the operation of that, and leave the rest of the individual platform to actually program the forwarding state and do all the other low-level things related to that, wouldn't this approach solve the practical application and network interworking problems? So one of the practical aspects is that trying to run an application on the router platform itself might not necessarily be the best idea. If the vendor can save $50 by putting twice less powerful processor there, vendor most likely will do that. On the other hand, how practical and from a stability perspective of view, from a security point of view, would you really want to run possibly third-party and not necessarily trusted code in the same address space, or at least in the same software component together with the rest of the control plane components? On the other hand, trying to run control plane adjacency, for example, running BGP to that same third-party application, which potentially can inject something into routing state, might also not necessarily be acceptable. Third aspect, which would be important purely from operational point of view, is try to reuse the existing model of how the networks are operated and have been for a substantial amount of time previously. Not to invent something really new, not the new data plane abstraction model, not the new forwarding state distribution mechanism, but try to rely on the current model, which is configure something, see the outcome, react to that. So Today, big portion of all this data is done via command line, via proprietary interfaces. netconf is getting to be there, SNMP is there, possibly some other interfaces. That is mostly tied to the configuration. Frequently, we need either more granular visibility into the actual state or to inject the entities, to inject the state into the system which is not configurable. For example, change the next hop value dynamically for a particular prefix if certain conditions are true. If those conditions are no longer true, we return it back. This is not saved in the configuration. Injecting the prefixes themselves, changing the attributes, changing the BGP communities, modifying filters or something else along those lines. If this reacts to the dynamic properties of the routing system, it should not necessarily be saved into the configuration. Another need is to have a standardized way of exporting certain events, statistics, and the operational state of the routing system back to the applications. Yes, there are existing methods today relying on parsing the command line output and similar mechanisms, not necessarily very reliable, not necessarily very practical. So looking into the requirements of what is needed here, two parts: the interface, which defines all the signaling components, the actual protocol used for that, whether we reuse something that is already existing or whether we define something really new. And then the actual description of the information which is exchanged there, the data model for what we are trying to put or get out of the routing system. Those are two interrelated components, and with the use cases, we'll try to see what are the requirements for them. Looking into each platform, two parts. We play with control plane here. The control plane still stays there. This is just augmented. And the actual data plane is left aside. So from the interface of this interface, from the interface of the solution, it would look like trying to inject the state into a protocol-specific RIP, which then the platform transforms into the global platform RIP. The process might be influenced, and then it is transformed into the platform FIB, which is later programmed into the hardware. So FIB changes are out of scope here. This is a platform specifics. The whole context of this mechanism is to try to modify the routing system state. For illustratory purposes, this is how the interfacing to the separate components might look like. We still have the control plane. It's still the same protocols running. They're still exchanging that same information. The ITRS interface modifies, adds something, or possibly removes something out of that information which is exchanged there, and how that information is transformed from one RIP to the other, and how that is put into the platform platform FIBs. Another component is providing the standardized interface of statistics related to the control plane operation, statistics related to the RIP, statistics related to the actual data plane aspects important from this context, and so on. Looking on a wider perspective to the several network elements, they can be controlled by the same entity, they can be controlled by the separate entities, and the synchronization between the controllers or synchronization between the applications which feed or modify the state into the routing system is out of scope of itself, of this architecture. If there needs to be a coordination, that's application level coordination problem. Whatever gets fed from the application is treated as trusted. The application is expected to understand what it is trying to do. So the whole model, similar to the current command line based or some other interface based approaches, export some events, export some topology, export some of the data, do something on the application side for that, feed it back into the network elements, and observe what is happening, and repeat this as a control loop further. The control plane is still there. We are not replacing that. We're not modifying that heavily. It's still there. All the adjacencies, all the control plane messaging exchanges are happening there. This is used to augment that, to add additional components, to modify certain operation aspects. So what can be this used for? Possible use cases. There's nothing really new. What can be done today via means of modifying the routing infrastructure can be achieved here. The main difference is that this might present a more or less standardized interface and more flexibility into what can be seen and modified. So, for example, trying to modify the routing table, the RIB, changing costs, attributes, other metrics specific to a particular protocol RIB, modifying the BGP policy in a context which might be outside of what BGP itself can do. For example, taking into account the application level performance, which could technically be expressed by certain use of communities. However, by some additional mechanism, if the application sees a need to modify the routing, it can signal that into the network. Selecting or controlling which of the multiple paths is being used and for which particular type of application, for which particular type of traffic. Getting the existing topology of the network, not necessarily what should be there, but what is actually there. Taking into account all possible failure cases, possibly the actual data plane usage matrices and similar aspects. Controlling of the local packet level protection, whether protection needs to be done for all the prefixes present in that particular element, only for a subset, whether that subset can be modified dynamically. Do you really need protection of the magic 50 milliseconds for all 500,000 prefixes which you might have on a certain network element? Most probably no. However, if you might need that only for a subset, and that subset might be dynamically changing. Controlling the black holing in a centralized way for protection against the denial of service type of events. Trying to influence overlay topology, or in general dynamic topology based on actual current traffic demands, based on time of day, based on application requirements, some external policy. Doing the centralized control plane operations, assigning certain attributes, assigning parameters centrally and not spread across all the network elements, and expect the control plane to propagate that. Exporting the events of the link went down, the prefix metric has changed, there's a new, more specific prefix injected into the routing system, similar types of events. Automating the data plane validation and OAM mechanisms. If certain prefix is in use, we might dynamically signal to the data plane liveness component to start the data plane, to start the validation session among a set of peers, and not just blindly across the full mesh of possible endpoints. Controlling how the composite links, the bundles or ECMP paths are used and for what particular traffic and how, and injecting the routes, routes which are used for any cast topology dynamically based on load, based on policy, based on something else. Looking a little bit deeper into a few of the more interesting use cases. In an exchange environment with a route server, the data plane validation. So if we just blindly run BFD or some other data plane validation to the route server, that does not necessarily validate that the data plane between the two actual pairs is valid. So if in this case we have the mechanism to export the event that one pair has actually selected the prefix received from the other as the best, that can be seen as a trigger to BFD or to some other data plane connectivity validation mechanism to trigger the data plane validation session dynamically. If that path is no longer the best, that session can be torn down. fast convergence and reaction to the network failures. Instead of trying to rely on the current propagation model where events are flooded sequentially across the network elements, in case of a failure or an event of the prefix went down, the interface went down, or something along those lines, signal this event to a central entity, to the controller, which then spreads it out across to the network, and not waiting until that same event is propagated over the existing control plane sequentially, hop by hop, to all other interested nodes. Potentially this can affect the operation of the fast readout and the packet level protection by simply informing about the failure much faster than it would have been over the sequential flooding. Modifications to the BGP policy possibly outside of the scope of what BGP can do today with existing set of attributes. Defining the optimal reflection, defining the per client reflective use, where each particular reflector client sees what is optimal for that client and not necessarily what is optimal globally for the whole reflector. Going to an extreme, possibly taking the centralized decisions across the whole autonomous system and just feeding back the results into each and every BGP speaking node, and not running the decision process distributed across all the elements. Pre-computing the whole BGP topology and distributing that, and just exporting the events which are happening there. Again, what can be achieved with BGP, with the current BGP attributes? It would be a superset in a sense that this mechanism would allow you to have the global view of all the state in the routing system and affect that as a one entity and not as a set of distributed routers in the network. Exporting the topology, and the important aspect is the current topology of what it is in the network and not necessarily what the inventory system tells how it should be. Exporting the information about the current utilization of links, exporting the topology tied to the current parameters in the routing system. And looking in the future, which is not currently in scope of the chartered work, this same mechanism could be used for configuring and creating that same topology. Awareness of the large flows and exporting that information into the underlying transport layers. So if the traffic demand between certain endpoints justifies the change of the underlying transport infrastructure, this can be used as a signaling mechanism, saying that the amount of traffic between the point A and B is larger than optimal. Therefore, the additional transport capacity needs to be provisioned. If that falls below certain threshold, it can be removed back. The components of the solution, so two parts of that. The signaling mechanism, which is not necessarily a very complex problem to solve, and the data model, the definition of the information which can be imported, exported, and how that is presented to external entities. The current thinking and where the work is leaning into is to try to reuse the existing netconf and YANG approaches, so netconf as a signaling protocol, which might seem to be too heavy and too much layered approach, especially in the use cases where there might be a need to modify a substantial amount of state, both from a speed perspective and both from a quantity perspective. And YANG as a data model for describing the actual interfaces and the information presented and imported. Most likely this will be based on Yang. However, we cannot just reuse the current definition as it is used for the configuration for the reason that much of this state is not a configuration one. This is just what is injected dynamically. There's no underlying configuration which backs that particular state in the routing system. So if you inject a prefix into BGP, not necessarily that prefix is visible in a configuration, and it should not be in this model. If the router goes down, if the BGP session is torn down, if the BGP process is restarted, that injected prefix disappears. And then it is up to the controller when the node comes back again to inject the same state again. This is not what is in the configuration. And looking from a perspective of how that can be modeled with Yang, Yang tends to treat all of these entities as a configuration. Technically, it can be marked as this is non-config entity. However, it's not very easy to describe the entities which do not have anything related to the underlying config. How this matches from how the operational state combines from separate sources. If you look at the network element as a whole, there will be separate sources of the information fed into it from a configuration of one or the other type of protocol and from the I2RS mechanism. Out of the configuration, it is transformed and derived into the running state, and via I2RS, it is fed directly into the routing state of the element. I2RS state is non-persistent, and this is by design, and it should not be retained. It is not retained across the reloads, across the process restarts. It relies on the controller to be provisioned back again. Some state might get propagated. For example, you get a BGP prefix injected in one node, and if the policy does not filter it out, that same prefix can be propagated as a normal BGP prefix, and it will be certainly accepted by the remote peers. However, the local policy changes, for example, changing the next hop attributes, changing other attributes within the box stays within the local element, and that information is not propagated anywhere further. So with this brief overview of the overall architecture and the use cases, what I would like to ask for the audience here is two things: to criticize whether this is a really wrong idea, and at the same time, whether there are other pain points not listed here, which you would see as possible candidates which can be addressed by the I2RS type of solutions.
Okay, the microphones are open. Anyone have any comments or questions to these points? Otherwise, I'm sure there are various avenues where you can give your feedback as well. Oh, here we go.
Hi, Hugo from Stargate Connections. You mentioned Yang and NetConf a bit, and I'm just wondering about the relationship between the folks working on Yang and NetConf and the folks working on I2RS, if there's some, kind of cross-pollination or how that works.
It is, yes, definitely. So the NetMod working group is Yang is specified in NetConf and NetMod, the actual models, and the NetMod group is actively involved into the requirements of how to address this non-configuration aspect of Yang.
Okay. Thank you.
Rüdiger Volk, Deutsche Telekom. Just to make sure that confusion isn't happening, you are not, well, okay, you are happy with Yang as the schema language?
More happy than not happy.
Okay. So kind of what you are looking for is, well, okay, you have your particular requirements, and, well, okay, so you have to do the models using that schema language, and for people less involved with IETF, well, okay, the NetMod group is doing essentially the schema language, and maybe a few examples of first usage, but kind of the domain experts have to do the actual specific models.
So first comment about the applicability of Yang or non-applicability of Yang here. Probably Yang is the best what we have at this time for expressing the description of the data models, which can be used in the system. Not saying that it is an ideal one, it probably will need substantial modifications in order to be practically useful here. Probably the biggest concern is the netconf part of this equation. Yang as defined running over netconf might be a too heavy signaling mechanism for that. However, Yang is rather tightly tied into the netconf part of the equation. Talking about a particular data models, if you look at what you can configure based on, for example, not yet existing BGP module for Yang, you technically can reuse it. You can use it as a mechanism to modify the attributes which are reachable over the I2RS interface. So from that perspective, it is mostly equivalent to configuration. So if it exports descriptions of communities, next hops, AS paths, and all other attributes, it can be used for it can be used as a data model for I2RS. The bigger problem is if you want to modify full global table today and twice a second, probably Yang running over netconf is a way too heavy mechanism for that. On the other hand, configuring something or feeding the state into the box is one thing. You also need to export something back. And for this, there might be a requirement to there definitely will be a requirement to specify vendor-specific extensions for the modules, as vendors tend to implement specific features which are as a superset of the base specifications of the protocol. So to summarize that, I don't see a major obstacles of Yang being used here. However, as it is today, it's not directly applicable. The work is moving into that direction, however, it is not there yet today.
Any other questions or comments? Okay, thank you very much.
Thank you.
I do have an announcement to make as we go to lunch. We do have one more Xbox One to give away, and so that is going to be the next survey drawing, which will happen at 3:30 today. So please fill out your surveys and give us cogent and useful feedback. Thank you.